Okay, so today we are going to solve Bitcoin median problem, 128 longest consecutive sequence. This is really popular problem. They have a lot of likes, so I'm going to solve this problem. Okay, so the starting time is 7:53. So let's take that as a note. So in a real interview, we have around 45 minutes. So we want to be mindful about the time. So yeah, okay, this is gonna be a starting time, and then we're gonna time it our progress here, so that it's like a real interview. Okay, let's start reading a problem. Given an unsorted array of integer nums, return the length of the longest consecutive element sequence. Okay, you must run an algorithm that runs in O of n time. Let's take a look at the example. 104, 200, okay. And output is 4. The longest consecutive element sequence is 1, 2, 3, 4. Therefore, its length is 4. 1, 2, 3, 4. Oh, okay. I see. So if I understand correctly, this is not sorted. Yeah, this is just unsorted array, and then the longest consecutive element sequence will be the number that is increment by 1. The reason why it's 4 is because there's 1, uh, and 2, and 3, and then 4, and then there's no 5, so the consecutive sequence will stop at 4. And then start from 100, there's no 99 or 101, so that's 1, 200, that's 1, and so on. Okay, I see. I guess in this step, it's important to ask clarifying question in real interview, I guess. But I guess there's like constraint here, so yeah, we don't really need to do that. Array size will be, it could be 0. Okay, interesting. So that's one thing to know. It could be that it could be 0, and then that it can contain negative number as well. All right, I see. Yeah, so let's start looking at the problem and solve this. So I guess yeah. If we ignore the fact that we have to solve in O of n time, I think it will be really easy to solve. This will one way we can solve this is by using using the sorting method and solve this in O of n log n time complexity, where n is the number of element inside of the given array. What I mean by that is, let's say this array is given, and when we sort it, it will look something like um, it will look something like this. And what we can do, oops, I need to add 4 here. What we can do is start entering from the first part and just see if the next element, or actually check the previous element and current element, and if it's difference by 1, then we're gonna increment the counter by 1, and so on. We're gonna continue until it hit to the part where the incrementation is not 1, which means we need to stop the sequence and update the maximum if needed. Update the counter if needed, and yeah, do the same process over and over again, and return the counter. This time, this will take, as I mentioned, this will take O of n log n time, and this is not going to meet the requirement here. So I guess I should meet the requirement here. So this approach wouldn't work. So let's start thinking about it again. So when we, when I'm looking at this problem, or the number in particular places like 100, to make a consecutive element sequence from 100, it needs to have 99 or 101, right? Or let's say just less, like, so 99, we're looking for 99. So in this array, if we don't have 99, then the counter will stop at 100. A counter will stop at 1. The consecutive counter will stop at 1. So I guess I can do that. But lookup time will take O of n time to find 99, but we can use hash set or hash map to sort of reduce that time complexity by O of 1 by having a trade-off with space complexity there. Okay, let's think about it. So for same thing will apply, we can search for 3 and so on. Okay, let's think about a custom input here. So let's say for 3 and 2, well, let's make it unsorted here in no particular order. Um, let's say we have the set of number. So it will be 4, 3, and 2 and 1, or 1 and 2, let's say. And then we can sort of see that we're going to start iterating through the array from the first pointer right here. And let's see, from 4, we want to find 3, if 3 exists or not. 3 does indeed exist, so the consecutive counter will be 2. Now what I want to do is from 3, whether 2 exists or not. So 2 actually exists in the set, so it will be 2 and so on. So it will like propagate, I guess. Okay, I guess that would work. Okay, I see. So, do I need to use a recursive function here, or without using recursive I can solve this? Not really sure. So what I'm thinking here is that when we are at the current element 4, we want to find 3, right? If we found 3, then now we want to find 2. If we found 2, we want to find 1, and 1 to 0, to -1, and so on. And at some point, it will stop. In this case, it will stop at 0, right? When we try to find, well, stop at 1. When we try to find 0, it's not going to be found. So maybe at that point, it will return. If there's a recursive function, let's say like 4 to 3 to 2 to 1 recursive function, we can, at the base case where we cannot find any number, it will return 1 and then accumulate. And then at this index, we can store, like, let's say, like, is that going to work though? Interesting. It's not, might not going to work. Um, hmm. Okay. Interesting. Okay, so I guess I have one idea, but it might be overcomplicating stuff. But yeah, I have one idea to solve this problem using hash map. Probably we can do this using hash map and recursive function call. So basically the idea is that let's kind of break this down in an easier way so that it's easier to visualize. Right, so we have this. Well, it's really ugly indentation. Let's fix that. Key value pair. So essentially what I'm doing is basically storing the element and as a key, and then I'm storing the frequency, the consecutive element from this particular key as a value in a map. So let's see. So let's change this example up here to 2 and then maybe like 4 or something like that. So we're gonna follow the same logic here, right? So let's say we are at 2. We want to, we want to find the downward consecutive sequence. So what I mean by that is from 2 we want to find 1. So this is going to be essentially so 2, and then this will be stored inside of hash map, so we can easily detect it in all of one time if 1 exists or not, right? So 1 exists, and if it is equal to 0, then we're just going to keep finding towards it. So 2 to 1. Now we're at 1, right? This is going to be essentially a recursive function call, and we're at 1. And now what we want to go is downward consecutive sequence. So we want to find 0, but 0 doesn't exist in this hash map key. So we're gonna stop that. We're gonna stop it there, and we're gonna, so recursive function call will, so from 1 it will return 1, and then 2 it will accumulate the counter. So at 2 we can say that the consecutive sequence will be 2 so far, right? So let's say this is call stack. Maybe visualizing call stack might be easier. So let's start over again. Let's say here. So function call from the index at 1, right? Index at 0. which element E is equal to 2. The element is equal to 2. And then now what we want to do is start find 1. 1 is found. So basically what we want to find is index. We don't really have to keep track of it. Now we found 1, and then we are trying to 1, and well, now we want to find 0, and 0 is not being found in this hash map key. So we're gonna return 0 from here, and then this call stack will get 0 as a result, and then we'll add 1 to it, right? Because it's a consecutive element, we want to add 1 to it if we found something, and then from 1 it will add plus 1, so the result will be 1, and then this 1 will be returned to the previous call stack, which will result in receiving 1 here, and then adding 1 again, and then this, and then at element of 2, it will be value can be stored as 2 here. And element 1, as we discussed already on previous call stack, it will be 1, stored at 1 here, and so on. So we're gonna move on to 3 now, right? And 3, when we look at so it will, the reason why we're going to 3 is basically the incrementing, right? Incrementing the array 1 by 1. So we are at 3 now. Let's see the hash map. It is 0, so we haven't encountered any consecutive sequence yet. So we want to find it, and so we're gonna look for downward sequence. So we're gonna start looking from 2 is equal to 2, and actually 2 is already computed here, right? 2, we already know that 2 gonna be the longest consecutive sequence. It will be 2 when the key is 2. So this will simply return 2 here, and then we'll receive 2 and then plus 1, which is going to be 3, and so on. So we're going to sort of do this step every time. So 1, we already computed this, so we don't have to compute that yet. 4, we're going to do the same thing, and the result will be 4, and this will done the iteration, and then iterate through the hash map, get the largest value of the largest values from the hash map, and then return it. I think this idea works. So this is sort of like a DP, dynamic programming concept, I guess. This hash map is sort of like a memoization in a way. I'm pretty sure I can solve this more cleaner without using recursive function, but we will see. We will see how we can solve this without our recursive way. But for now, I think recursive way would work. So let's start writing in code here. So right here, so okay, let's write the timeline here. So 8 o'clock, 8:06, we start coding. We finish the sort of conceptualize the solving thought process here. So let's start writing. What we need is a map of integer and integer as a consecutive sequence, and the key will be key is the element. So let's say map. This is a very bad variable name in a real interview, but for now, I will just call it map for now. And then what we want to do is pretty much register all the number into this hash map. Dot put this n as a 0. Do we have any duplicates element in this array? It wouldn't matter because we are not incrementing it from here, so that should be nice. That should be fine. And what we want to do is basically, yeah, just keep iterating through. Do we need? I don't think we do. Iterate through here, and what we want to do is call the helper function to sort of start finding the element, right? So what we're gonna do is let's call recursive function find consecutive from the particular number that we're at. So we're gonna pass in the n, the current element, the pointer that we're at, which is, in this problem will be 2 in the first index, and what we want to pass is a map, right? And we want to sort of decrement one by one and then look up at the map and whether that number exists or not. So this is going to be a recursive function. Let's assume that we already implement this function, right? Yeah, let's assume that we already implemented the function. And then after this, this recursive function will register the frequency into the map. So as we discussed before, what we want to do is afterwards, we're gonna iterate through this value here. I think we can just do values. I believe this is the right syntax. And just say, um, term res here. So here, finding max consecutive sequence, and this one is computing consecutive sequence, and just this part is just registering to the map, so it should be easy enough. Yeah, so this is a really core logic to this problem, right? So this is really important to sort of start writing it out. Let's see. So we want to return, we don't want to return anything, and this is gonna be our function name. And then what we're gonna do is just pass in the number that we were looking for, and we're gonna pass in the map of integer and integer, same map. And we need to write the base case here. I'm pretty sure there's an easier way to do this than recursive call. I'm sure there is, but for now we're gonna go with this way. Yeah, we can just do it iteratively. That's okay. So base case would be, let's say if the map doesn't contains the key, if this current number doesn't exist in the key, then we're just gonna return 0, right? As we discussed already. And also there's one more base case. Since we talk about this map is going to work as like a dynamic programming memoization, the similar concept as that. So let's say we're at the point where we're at 4, right? We already computed 3. So at 4, what we want to do is we come at 4 and we haven't computed this 4. So we want to start computing it. So we're going to go down the sequence to 3 and then start counting from 3. 3 is already computed here. So if it is already computed, we don't want to recompute this again in order to reduce the time complexity, right? So what we want to do is immediately return this. So that's going to be a base case as well. So if map actually, so at this point it will contain. So what we can do is if map dot get the number is not equal to 0, which means, so we initialize with all the values as equal to 0, right? And if this is not 0, or let's say if it is bigger than 0, that means we already start counting it. We already encounter or computed this value before, so we can just return that pre-computed value. So just like same as DP concept as well. So what we can do is just simply return that, right? And then what we can do here is that we would like to find the consecutive here. So we will call this and make sure to do -1 here. And this is going to be your result. And then make sure we want to do +1 here from the previous result because we're finding consecutive sequence. And then what we want to do is make sure to put this one into the result as like a DP registration, memoization concept. And then what we want to do is just return the result here. Okay, I think this would work. Hopefully it will. Well, let's check, right? So dry run. In the real interview, it is really important to dry run the code that you wrote to check the correctness of your code. You don't want to just simply say that, okay, I'm done with coding. Uh, I think this is good enough. You don't want to say that. You want to write the bug-free code, and that is really important. That is one component that the interviewer would evaluate on your coding skill. So those are pretty important to test. So let's actually write the timeline first. So 2013, we finish coding. So it take roughly 20 minutes. Okay, not a bad timeline. Okay, let's start drylining the test case here. So this would be our test case. So let's start running this code. Okay, so we initially gonna initialize a map as initialize a map first, right? So that's what we are doing here. Disgusting indentation. So let's fix that. Okay, so 100 is all initialized with 0 because we haven't computed the consecutive sequence from here. So this step, initialization step, is done, and we're gonna start finding the consecutive sequence from here, right? That's what we want to do. Okay, so well, let's start doing it. And so it is going to be 100. What we want to do is from no. We are looking at here, right? So iterating through number one by one, element by element. So starting from 100, find consecutive sequence will be called, and then from this let's see, right? So does 100, so n will be 100 and map will be this. So let's actually write this down, copy and paste this to here so that we can easily track the call stack here. So we're currently at 100. Obviously map contains the key, right? So we don't have to we are not going into this if statement, and we are not also going to the if statement as well, because since it is 0. So we're gonna find consecutive sequence with 99. So we're gonna go to 99 here. So now right now n is equal to 99. It was used to be 100, but now right now it's 99. So now we look at the 99. If 99 exists in the map, no, it doesn't exist. So return 0, right? So in the previous call stack, when the n is equal to 100, it will get 0 as a result, and we will add +1 to it. So the result will be 1, and then the map, we're gonna register this result in the map, so it'll be 1, and return the result. Which is not right? Because we don't want to return anything here, right? Okay, that was close. That was a one bug, because this is essentially a void. So yeah, that's pretty much it. That's done. That's good. And yeah, it's 100 is done. So we're gonna start entering for 4 now. Oh yeah, 4. So from 4, what we want to do is basically start looking for it again. So n is equal to 4. And then n is equal to 4. Obviously, it's not going to go in here, right? And then it will call this function again, the self function, recursive call. And then now it's equal if n is equal to 3. Same thing again. It will go down to n is equal to 2, and n is equal to 1, and it will go down to n is equal to 0, right? Because it doesn't go into this base case, so it will keep recursively called your own function until it get to the base case. So n is equal to 0. We will eventually get there, and then map doesn't contain this key, right? We don't have 0 as a key in this map. So what we're going to do is just return 0 from here. So this will return 0. And then this will get 1. This will get 0 as a find consecutive function. And then we will add +1 to it. And then we're going to add it to this and then return 1 as a result. Which in this call stack, when n is equal to 2, this will get the result as 1 and then +1 to it, right? This will return 1 when n is equal to 1, and then we will add 1 to it. So, and here the consecutive will be 2 here from the element 2. And so on, we're going to repeat this process over and over again. It will be 3 here, and then at 4, it'll be 4. So that's done, right? So that's perfect. We finished this element, and then now we're going over from 200. So let's check 200, and yeah, let's start checking it. So 200, and then we're gonna go down to 199, which is not gonna be found, so return 0. And then at 200, we're gonna get 0 plus 1. Oops. And then we're gonna store that as a map, so it'll be 1, right? And then now, interesting part here, when we encounter 1, we're gonna go in here, and it will catch by the base case because we already found it, so we're gonna simply return it. So it's not gonna do anything here. 1 and then 3 is the same thing, and 2 is the same thing. It will catch in the base case every time. So it will be return the same result. So we're not gonna compute the call again from, let's say, from 3. 3 is already computed, so we don't want to compute this value again by searching going down to 2 and 1, 0 and -1 and so on. We already computed that, so we're gonna use that value. We don't want to recompute it again. Why not? So yeah, I think it works flawlessly, which is good. I think computing consecutive sequence work pretty fine. So now this part here. So integer value map.values. So we're gonna iterate through all these values and then try to look for the maximum number here. So we're gonna do math.max, compare with value and result, and then finally return the result. Yeah, I think it will work. Let's check some edge cases here, right? Edge cases are really important to check. Edge cases, maybe the elements of 0 or something like that. In this case, map, well, nothing will be in the map. Find consecutive, it's not going to array any array. And then the result will be 0, but the map has no entry, so it's not going to do anything and return result 0. Yeah, it will return 0 as a result. I think that's totally fine. So edge cases completed, that's good. Checking edge cases is really important in real interview as well. So yeah, I think it works pretty good. Let's see. 2021, we finish dry run, which is good. Yeah, I'm fairly confident about this solution, unless there's some. Ooh. Oh wow, 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 wow. Interesting. Okay. Well, yeah, this is not good. Okay, so yeah, obviously I found a problem here. This cannot be void. It's actually need to be integer. And what we want to do is we definitely want to return this result here. Yeah, definitely. I think yeah, I couldn't. Okay, well, that was pretty bad. Well, let's submit it first and then see if it runs. Okay, it's good. Well, yeah, I previously solved this question actually around around 8 years ago. So okay, well, I totally forgot that I solved this problem before. So that was fresh. Let's run again. 80 milliseconds is pretty slow. Okay, well, okay. I don't know why it's so slow. I think there's a simpler way of doing it. But okay, let's analyze time complexity here. I think I should have done that before running. So time complexity will be O of something, and then space complexity will be O of something. Here we need to compute the worst case. So let's examine. Space complexity. What we are using is a map and just function call stack here. So it'll be O of n. It's pretty simple. And time complexity is a little bit complicated to calculate, but let's consider that there's a sequence like this, right? It will be the worst case here, that all the elements are in the sequence. And from 1, well, maybe at 1, we're gonna compute, so 1, we're gonna compute some from 1 and 0 not exists, or 1, the consecutive sequence is 1. 2, it's 2, right? Because we computed 1, so return 1 from the recursive stack, and then 2 will result in 2. And 3, same result. 4, same result. 5, 6, 7, and 8, same thing. So this function will be, so each function call will be finished in all of one time in this case. So let's reverse this order, and then let's see if the other side will work as well. So 8 from here, we will start thinking that 8, from 8 we're gonna go downward, right? So we're gonna find 7, 6, 5, 4, 3, 2, 1. And then now that we know that 8 has a sequence of 8 and so on, right? And then we're gonna go down for this array after that recursive call from 8. Find consecutive recursive call from 8. 7, we already computed that. We don't have to compute that anymore. It will be catched by this function, this if clause, and we're gonna just simply return the result here. So 7 will be O of 1. So 8 will be O of n times the complexity to run the find consecutive. 7 will be O of 1, O of 1, O of 1, O of 1, and so on. So the complexity here will be O of 2n, where we can just ignore the constant here, so it will be O of n. So overall time complexity of O n as well. So overall time complexity, spin complexity, both of them were O of n. I used the space complexity trade-off of O of n to reduce the time complexity. Yeah. I think this is what we can do to reduce the time complexity. Yeah, so I use the recursive function call to sort of easily simply find the downward consecutive, but there might be a way to do it in the for loop, and there might be an easier way to do it because there's got to be a way to do it. Yeah, there's got to be a way. But yeah, anyway, I think it was good to solve this in within how much time? Yeah, so I think we met the requirement. We solved it optimally with O of n. Let's actually look at the solution here. So they solved it in O of n and O of n. Okay, I think the best complexity of O of n and O of n. Okay. Yep. Okay, so I think I solved it optimally. I haven't looked at the solution directly yet. But yeah, it was. I think it was a pretty good run. So in total, total time spent of this problem was, let's see, 53 to 21. So 53 to 23 would be 30 minutes. Minus 2, so 28, I believe. 7. Yeah, so 28 minutes. I was able to solve this LeetCode medium level problem, which is pretty good. To go over overall performance, I would say there's one mistake. I think communication wise, I think it can be improved where I'm um, explaining the call stack here, right? The recursive call stack. I think this can be improved to explain it more thoroughly so that the beginner can even understand. Um, and also, yeah, also explanation. This is one thing that I want to mention. Um, Even though your explanation is not great, it is okay. In a real interview, you're interviewing with the people who knows the problem really well. So typically in let's say like a Fang, right, or a Mang right now, because Facebook, changed their name to Meta. Interviewers typically know what they're doing, right? They keep like providing the same question over and over again to the candidates, so they know the problem pretty well, how to solve it suboptimally, how to solve it optimally, and then they oftentimes have a follow-up question, and they know what they're doing in a question. So and then also they know various solution throughout the interviews they conducted before. So even if your explanation is little flawless like I did, it should be fine. They probably see this approach before. Interviewers, when you explain the thought process to the interviewers, they probably see the same approach before, so it should be fine. They will probably gonna understand. But it's always a good idea to check in with them. That to like check in with them if they're following the logic that you're talking about. Yeah. So communication wise, it was okay, I would say. Time complexity analysis, space complexity analysis, I think it's correct. I'm fairly confident that it is correct. And then yeah, dry run test cases with the normal input, custom input, and also testing the edge cases. Those are important. So I did all of that. So I think it was good. Yeah, coding wise, I think coding ability, I was able to implement it without any having any problem. So it was fine as well. Problem solving was fine as well. One problem that I found was that there's one simple bug that I had, and I wasn't able to fix it with the dry run, which is kind of bad. So one simple bug that I missed, which result in um, not the perfect coding correctness, but hopefully it's not gonna be that bad, too bad of the evaluation there. But yeah, overall, I think it went pretty well. Yeah. Hopefully you guys can learn something from this interview, mock interview sort of thing by myself. If you have any question, comment down below, and I'm happy to answer that. Thank you for watching. See you next time.